Comes on everyone. Let's start off. The last thing that we did, we were doing minimum distance. Great. Let's go ahead with this. So let's say we got a river which is going with speed u. And now we got a person here. So velocity of this man in still water is v, and v is greater than u. Now what he started doing, he started actually going in a square. So for a person who is standing outside, and when you look at him, it feels this person is actually going in a square. So he's swimming along AB, then he's going to BC, then he's going along CD, then he's coming back from D to A. So this is a square of length L. See, he's actually swimming along the square. Man swims along ABCD. Find the time taken. For one round trip. So to start from A and come back to A, how much time will it take? So the person who's standing outside the lake, when you look at him, you can see this guy is just going in a square. His speed is v, which is greater than u. The river is going with u horizontally. This is a top view. Find the time taken for him to complete one round trip. Hope the question was clear. Give it a try. Others do keep your cams on. Any ideas here? So basically, this is case one and case two combined. So what is happening here? First, ask yourself, if you want to go along AB, are you actually going along AB? So when you're going from A to B, this person is actually trying to swim in this direction. Remember, this was case two, the minimum distance. Because if you want to go in a straight line, you have to swim at an angle. This was angle theta. So you're actually going with v cos theta. And this velocity was v sine theta. So you have to cancel a part of, with your velocity, cancel the reverse thing. So from here we get v sine theta is equal to u. Sine theta is equal to u by v. So time taken to go from A to B will be L by v cos theta. We did this thing. This is case 2 ka result. L by root over v square minus u square. Then you're going from B to C. So when you go from B to C, the river is helping you. This is with the river, so v plus u. So time taken to go from B to C is L by v plus u. Similarly, when you're coming down, same story. When you come from C to D, again, you're swimming in this direction with v at an angle theta. The time taken to go from C to D will be again same as A to B, root over L by v square minus u square. And then when you're going back from D to A, you're going opposite to the river, which is v minus u. So time taken to go from D to A will be L by v minus u. Therefore, total time, just add them up. 2 times L by root over v square minus u square plus L by v plus u plus L by v minus u. Yeah, you can simplify it further, but you got this. All clear with this. So this is a combination of case 1 and case 2. Yeah, it's a big one answer. Any doubts on this? So how is this guy actually swimming? If you look at that square, when he's here, he's swimming this way. He's looking this way and he's trying to swim this way. So you're swimming in that direction, but you're going straight. Here you're swimming with the river. Here you're swimming this way. You're trying to swim this way. So you're looking somewhere else, but you're coming somewhere else. And you're going here. Clear with this? That's how you're actually swimming. So you're looking somewhere else, but you're going somewhere else. So that's a combination of case 1 and case 2. Case 3, minimum time to cross the river. So you just want to cross the river in the minimum time. It doesn't matter where you reach. Again, same story. So this is A, this is B. Since we don't know how he is going to go, let him go with V at an angle theta. We can clearly see the velocity responsible to cross the river is V cos theta. V sin theta is fighting with the river. So time taken to cross the river will be d by V cos theta. And you can clearly see if you want to make this maximum or minimum, cos theta has to be maximum. For minimum time, cos theta is 1. Basically, theta is 0 degree. It kind of makes sense, isn't it? If you just want to cross the river in the minimum time, why should you waste your speed, fighting with the river? Use all your velocity to cross the river. So the minimum time would be, so this is what would happen. So you just have to swim straight. Forget about the river. You swim straight. So you swim straight, but then this is what would happen. You won't go straight. You will actually go at an angle. You're trying to swim straight and the river is trying to drag you to the right. So you go in this direction. So this is how the person will look. The person is looking ahead. You're looking ahead, but you're going at an angle. So instead of reaching B, you will reach some other point C. This is called drift. So you won't reach B in minimum time. You will go somewhere else. There. So the time minimum is D by V. That BC is called a drift, the horizontal distance along the river. Horizontal velocity into time. In this scenario, it is u into the river ka velocity into the time is v by d by v. That's your drift. So in the minimum distance, you will travel minimum distance, but time won't be minimum. In minimum time, the distance won't be minimum. You can't have both. All clear with this? So if you just want to cross there in the minimum time, don't waste your energy. Put all your effort along AB and cross the river. Yeah, but the side effect, you won't reach B. This is your case 3. Case 4 is an interesting one. So there are total 4 standard cases here. With the river opposite to the river, minimum distance, minimum time, and the minimum drift. Now, if you remember case 2, the man was able to go to the opposite point because you can swim faster than the water. But what if the speed of the man is less than the river ka speed? So what happens because of this? He can never reach the exact opposite point. If this is the scenario, no matter how much effort you keep, you can never cancel the river ka velocity, isn't it? Even if you put all your energy opposite to the river, you will still get drifted away. So if your speed is less than the river, you cannot reach the exact opposite point. Then the question is, okay, if you can't reach the exact opposite point, so what is the closest you can get? That's why we call it a minimum drift. There are 2 ways to do this. One, pure differentiation. The second technique is really good using vectors. I'll teach you both. Uh, and I want you to remember the second one. It helps a lot. First, let's do brute force integration or differentiation. So A, B, every time the story is the same. Let the man go at an angle V theta. So the speed along the river is V cos theta. This component is V sin theta. The river is dragging you with U to the right side. Now, if you look at the man ka speed, in this direction, we have river ka speed minus your V sin theta. And this cannot be 0 because V is less than U. And in this direction, you're going with V cos theta. That means you will travel somewhere here to point C. This was B and this was A. So that BC ka value is the drift. So time taken to cross the river is AB by V cos theta, which is D by V cos theta. BC will be the horizontal velocity, U minus V sin theta into time. That will be U minus V sin theta by D by V cos theta. Means if you swim with different angles, you will get different distances. That will be UD by V sec theta minus D tan theta. This is your drift for different angles, everyone. Now among this, when you do maximum minima, there will be one particular value where the drift will be minimum. Now, like I said, this is pure max. You are just brute force, you're hitting it. So drift BC is equal to UDB V sec theta minus D tan theta. Maximum minima. So if you want to find the minimum value, dBc by d theta is 0 for minima. So differentiate this. UD by V, sec ka differential will be sec theta tan theta. And D ka differential will be D sec square theta. And this is equal to 0. And this, if you solve, you end up with sine theta is equal to V by U. You get a pretty good answer. If you see case 1, it was U by V. Here it is V by U. So it's easy to remember actually. Case 2 ka opposite. So if you swim with this speed, you'll have minimum drift. Then how to find BC minimum? Take this and substitute back again. BC minimum, you have to substitute here UD by V. Secant theta, how much is that? So we can make a triangle there. This is theta. Sine theta V, and this is U, and this is root over U square minus V square. So sec theta will be what? U by hypotenuse by adjacent side. So root over U square minus V square. You can see it is quite lengthy actually. मतलब answer तो आ ही जाएगा if you don't remember anything. And then you can simplify this. That will be d into U square minus V square. That will be d by V root over U square minus V square. This is your minimum drift, everyone. So if your speed is less than the river, this is the closest you can get to the opposite side. Pure maxima minima, once you got the function, it's just brute force at this point. So main thing is this. So V cos theta is helping you to cross the river. BC is coming because of horizontal velocity into time. And then you got BC and then differential. The whole thing is clear, what we did. Any doubts on the calculations or anything that you're not clear, please ask. Manav, Shlok, Shrikant, clear with this? Ahana, Dhruv, Rohit, Ananya, Soumya, clear? Now, the second method, alternate one. Listen to this carefully. It's a very useful method. Later on, when we'll see some questions, right? This thing will help you with, instead of doing all this calculus. This is using vectors. So first, let me explain this in basic. We are going to use triangle law of vectors. So if you have vector A bar, if you have vector B bar, we know the resultant vector is from the remaining tail to the remaining head. That is how we got the triangle of vectors. So R bar is nothing but A bar plus B bar. Similarly, if you remember in the Rainman problems we did, velocity of man with respect to ground is equal to, or in this thing, river ka thing, velocity of man with respect to water plus velocity of water with respect to ground, basically the river. You can clearly see the vector. So if you take V man with respect to water, and suppose if this was V water with respect to ground, then the resultant vector will be from the remaining tail to remaining head. This is velocity of man with respect to ground. That was the idea there. Okay? So that's your triangle law. Now see how to use this. What are we saying? The river will always push you horizontally. Agreed? River will always push you horizontally. But man has an option, right? When the man is trying to swim, he can swim straight, or he can swim at an angle, or he can swim like this, or he can even swim like this. He can swim in any direction. And now if you try to join all of them, you will notice this guy can go in a circle of radius V, isn't it? Is that making sense? This person, when you're starting from there, he can go in any direction. If you take all possible directions, it will look like they're forming a circle. The tip of all these vectors will form a circle. So these are all possible directions the man can swim. Now we don't know which one he has to swim, but these are all that you can have. All possible directions man can swim. And we can clearly see they all lie on a circle. The heads all lie on a circle. The head of the vectors lie on a semicircle. Perfect. That means among all these vectors, there is one vector which will give you the minimum drift. Right? So now see. Now the man can go in any direction there. So let's take it like this. So this is the circle. Now look at the vectors. This is velocity of the river. The river is always pushing this way. Now, the man ka velocity, if you choose any point, let's say if I take this point as man ka velocity 1, means if he decides to swim in this way, what is the resultant vector, everyone? From the remaining tail to the remaining, this is the velocity of the man with respect to river. Then the resultant vector will be from the remaining tail to the remaining head. That means this person must swim in this direction. Means he will go and he will land somewhere at this point 1. Is that logic making sense? Since you can take any vector on the circle, if I choose this vector 1, if when you join the head to tail, that is how the vector will look. Suppose if you choose any other point here, let's say point 2. Maybe I'll just put it a little up here. Let's say if you choose this point here, 2. Again, from vector law, if you join the remaining tail, so from here, we are keeping this fixed. And if you join this point here, means you will land somewhere here. You're getting the logic how we are drawing the vectors? So you can choose any vector on that. And suppose if I take a vector like this is 0.3. So if you choose that vector, then the resultant vector will be from the remaining tail to the remaining head. So meaning he will just keep going like this. So that will be 3. And when you look at this picture, you can clearly notice something. It's little geometry there. So which vector should I take? So on this circle, right? So this was your starting point. If you can choose a vector such that if the resultant vector becomes a tangent, if you want, I'll just draw those points again. See, if you take point 1, let's say if this was 2, let's say this was 3, and let's say this was 4, let's say this was 5. I'll take 5 points here. So if you take the vector 1, or if you take vector 2, or if you vector 3 and vector 5, so on. So if you take vector 1, you will go from here. You will reach somewhere here. This is point 1. If you take vector 2, you will go somewhere, you will reach point 2. See, you're getting actually closer to the minimum drift. If you take vector 3, you will reach here. If you take vector 4, you will again start going back. If you take vector 5, again you start going back. Are you getting what is happening? So the minimum drift will occur when the resultant vector becomes a tangent to the circle. And there is no math and all. You have to just see the diagram and figure out from there. So among all the vectors, if you choose a vector on a circle 0.3, the tangent, the resultant becomes a tangent. The minimum drift occurs when resultant becomes a tangent. Is that logic making sense? So literally I drew all the possible vectors and just checking. And when you check, you can clearly see the drift will occur for that thing, right? So this is the meaning of this point here. When you say 5, so if man chooses vector 5, he will reach there. That's the meaning of it. He reaches here. So yeah, then you're done. Remember, this is a very good, neat trick. Like when you have two vectors, in that one vector is constant and the second vector is rotating or second vector is movable, the minimum will always occur when it becomes a tangent. That's a very good idea there. So this is the velocity of the man with respect to water. This is the velocity of the man in the still water. This is the velocity of the river. It is pushing him. The resultant will be head to tail, and this becomes a tangent. This is 90 degrees. Let the man go with theta. Then this will be theta. This will be 90 minus theta. We can clearly see sine theta will be velocity of man with respect to water by velocity of the river. Velocity of man with respect to water is v and the river is u. Sine theta is v by u, which we got without any integration or differentiations. Is the concept clear? This we got using only triangle law of vectors. It's a neat trick. Remember that, useful. So when you have two vectors, one vector is changing and one vector is constant and you want minimum, this is one of the best thing to do. All clear with that, right? So different points will give you different things. The tangent will give you the minimum. Great. These are the four cases you should know, everyone. These are standard models. Yeah, but every time it need not be necessary that you will follow one of them. So let's see a few questions on this. Then I'll also show you one question, how it will be framed in advance. Mm, mm, mm. Yeah, let's get these two. Let's say the first one. A man can swim at 4 meters per second in still water in a swimming pool. He enters a 200-meter wide river at one bank and swims with respect to water at an angle of 60 degrees to the river flow velocity. So just always draw a small picture. The river is going with 5 meters per second. So that Yuka value is 5. This is not any of the four cases. He just gives some random data there. And you're swimming with 4 at an angle of 60 degrees with the at an angle of 60 degrees with the flow velocity. Be careful. This is not vertical. He is going like this with 4 meters per second with 60 degrees to the river flow. Matlab, he gave this angle is 60. Are you clear with that? The river is flowing right side. So with respect to that, you're going with 60 degrees. Now resolve the velocities into components. So this guy is actually going 4 cos 60, 4 sin 60. And what is the river doing? The river is also pushing you. So that will be additional 5 in the horizontal direction. So the resultant will be 4 sin 60 is 2. 4 sin 60 is 2 root 3. And this will be 5 plus 2. This is 7. This is how he's actually going. He's going away somewhere here. Let's call this point A and let's call this point B. He's going to reach somewhere here, C. Perfect. And that is your drift. What do you want to find? In how much time does he cross the river? What is the width of the river? 200 meters wide. So he's actually crossing the river with 2 root 3. So time taken will be AB by 2 root 3, which is 200 by 2 root 3. 100 by root 3 seconds. What is the drift? Who is creating the drift? That's 7 meters per second. So drift will be the horizontal velocity 7 into time. That's 700 by root 3 meters. All got the steps? So be careful with the angles. He said 60 degrees with the river flow. He didn't say vertical. So river is going horizontal. You have to take that. Any doubts on this? What about the second part? Let's get that also. Any doubts on the 68A part? Please ask me. A man can swim at 2 kilometers per hour, crosses a river to an exactly opposite point. Yeah, this is a straightforward one. This is case 2. Again, look at the word 120 degrees to the flow of water. Angles, be careful. Don't take with vertical. When I taught you, I took everything vertical, but read the question. Did he say vertical or did he say river? So he is going with 2 kilometers per hour. It's 120 degrees. So this is 90 and this is 30. So straightforward, na ho gaya. You want to get a minimum drift, so your horizontal velocities must cancel. That would be 2 sine 30. That must be the river cos speed, and this is 2 cos 30. Since you want to go straight, you must be equal to 2 sine 30, which is 1 kilometer per hour. This is direct case 2 ka problem. Easy? All got this? Yeah, that was straightforward. Let's see one more. Aeroplane wind problem. So they look different, but it is the same, man river problem. Instead of a man, we have an aeroplane. Instead of a river, we have wind. Next time when you get a chance, look at there is a direct flight from Bombay to Tokyo, Mumbai to Tokyo, Japan. Okay, just look at the flight. Okay, you will observe while you're going, it takes only 9 hours. While coming back, it takes 10.5 hours. There's almost 1 hour gap in time. So the thing, there is something called jet streams. Ever heard about this term? You have when water flows on a land, we call it a river. So similarly, you have just jet streams, which are in the sky. These things have some speed. So there are actually companies, which track these jet streams and sell that data to these aeroplane companies. So if you can take your plane on a jet stream, imagine you want to go from A to B, and let's say luckily there's a jet stream like this. So it's like a river kind of thing. So what you do, you take your plane onto the jet stream, so you get that additional speed. You can follow the jet stream, and then you can leave. You can save fuel. So you get like even if your speed increases by 70, 80 kilometers per hour, that's a good amount of time. So it works. Something similar happens with satellites also. In space, they have something called Lagrangian points. Like if you go along that path, your rocket need not spend even a single amount of fuel. You can travel distances without spending fuel if you can find that specific track path. That's where NASA uses all this. That's the reason NASA needs supercomputers to find that trajectory or path. It takes months for them to calculate. There is just so much data. Let's get this thing. So read the question, try to put a picture. Let's understand. Get me an answer. So we have an aeroplane which wants to go from A to B, 1,000 kilometers due north, meaning it is along the north. Before going ahead, let me teach you one small thing. Uh, Listen to this. If someone tells you you're going 20 kilometers per hour, or someone says you like this, 30 degrees north of east, what is the meaning of this? So listen to the word. Always draw like this: north, east, west, south. How many directions are there? 6. North, east, west, south, up, down. Don't get confused. When you ask people what is up, they will say Russia. if you go up, you'll go to moon. You won't go to Russia. If you have to go north towards Russia, you're getting it. So don't get confused. Up and north are not same. Now listen to the word 30 degrees north of west east, meaning from east. So from east, you are going 30 degrees towards north. Understood the meaning of it? 30 degrees north of east. So east say go towards north 30 degrees. Suppose if someone tells you like this, 20 degrees west of south. From south, go towards west by 20 degrees. Are you guys clear with this? If it is 45, there's no problem. You'll say northeast, southeast, and this thing. But what if you have some other weird angles? Just see one more. If I say 15 degrees north of west, and you will see these kind of terms. So from west, so the second word means north of west. So read it like that. From west, go towards north by 15 degrees. All clear with these angles? Right? So a little terminology there. No, let's finish it off. Yeah, standard mains level questions. Bits में mains में they do ask. In a paper of 25 questions in mains, you would get around like 10, 12 like this. Yeah, advanced papers are a different monster though. We'll see that next one. Let's get this. That's where most of your seniors get trapped actually. They see the mains paper and they think physics can be handled and they get slotted in advance. But max for them, right? They get slotted in mains also, they get slotted in advance also. So it feels normal. So not sure why max comes out of. So Anish says something. Okay, anyone else? Okay, let's understand the story there. So this is very important when you're a pilot, right? And you're going in a plane and there is a wind blowing. So you want to go from A to B. So let's draw the picture. You want to go from A to B. The city is 1,000 kilometers exactly on the north. So you took your plane, you just ignored the wind and you just kept flying straight. So you took your plane and you say like, okay, I'll just fly straight. And then you observed after 2 hours, you reached a city C, right, which is 300 kilometers northeast, meaning from B to C, this distance was 300 kilometers. Northeast meaning 45 degrees. So this is 45 degrees. So you went there, meaning this is what happened. You wanted to go from A to B, but you went from A to C. Meaning if you look at the plane, this is how the plane was trying to go. I'll just put something something like this. So the plane was trying to go straight. I'll just put an arrow. So the plane was trying to go straight, but you're drifting to the right. You're getting what is happening? You're trying to go straight, but your plane is drifting towards C. This is what happened. So when you see these kind of questions, the wind velocity is similar to river. Just don't see the words and get scared. It is the same thing. The aeroplane is the man swimming. So everyone got the scenario. What happened? The one thing that we don't know here is how is the wind blowing. So we'll start from there. So let the velocity of the wind be Vx I cap, Vy j cap. In this question, you actually have data, pretty nice data. You can see and figure it out, but let's do it systematically. So then what would happen? So if the wind velocity is this, and if you look at the plane, so the plane is trying to go straight with what speed? 500 kilometers per hour. And what did your wind do to you? The wind is also pushing you forward with Vy and horizontally with Vx. So this was point A, this was point B, this was point C. This is 45 and this is 300 kilometers. So this distance is 300 by root 2. This distance is 300 by root 2. And this distance was 500. So in the vertical direction, instead of traveling 500, how much did you travel? You traveled 500 plus 300 by root 2. And with what speed did you travel? You traveled with 500 plus Vy, the wind curve speed. In how much time? 2 hours. So 1000 or 500? Sorry, that is 1000. So we get Vy is equal to 300 by root 2 or 150 root 2 kilometers per hour. 150, 300 cos 45. Yeah, there's a 2 also will coming down now, 150 by root 2. In the horizontal direction, how much are you traveling? 300 by root 2. Again, who made you travel? The wind. What is the wind curve speed? Vx into 2 hours. So we get Vx is equal to, again, same thing, 150 by root 2. Okay, so you're traveling 150 by root 2 j cap, you're traveling 150 root 2 I cap. Your speed will be 150 and the direction is I plus j, north of east. All clear with this? But this question you could have done much faster. Look at the story there. You're traveling with what speed? 500. How much time you have? 2 hours. You're going from A to where? A to B. How much was this distance? 500 kilometers, right? So you can clearly see all this extra distance that you traveled is because of the wind only, right? You're getting the argument? The reason the B to C came is because of the wind. Agreed? That means the wind also must be blowing in this direction, B to C. How much distance was that? 300 in how much time? 2 hours. So what is the wind curve speed? 150 kilometers per hour. Which direction? Northeast. Is that making sense? You can just see and tell that way without doing all the calculations. Yeah, but sometimes you won't be so lucky. What if the plane itself is flying in some weird direction? Then it becomes complex. So always have one systematic thing. All clear with this? So aeroplane wind is same as river boat. Any doubts on this? Karthik, Shrikant, clear with this? The next one. Let's see how they can frame one for an advance. If you ever actually see a river, right? Rivers don't flow with constant speed. So we got a river here whose width is d. So we got a person here. Velocity of the man in still water is v. This river, if you see, let's take this as y coordinate. Y is equal to 0. This is y is equal to d. So if you look at this river velocity, right, it is changing with y. Means the more you go into the river, it is increasing faster. So velocity of the river increases linearly till the center. Next time when you observe a river, observe that the edges of the river is 0. At the center of the river, it is flowing fast. Velocity of the river at the banks is 0 and increases linearly. Now this is given. It increases linearly. I hope everyone knows what is linearly. When they say linearly, meaning the function will look like y is equal to mx plus c, an equation of a straight line. To speed u till the center. Let me show you how that looks. So the river V is 0. V is 0. As you're going toward the center, you're going faster, 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 faster. Then again, you're decreasing, 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 decreasing. So this is how the river is flowing. So at the midpoint, y is equal to d by 2, the river is flowing maximum. This is the maximum speed of the river. This is how generally rivers are, right? Now this guy decided to cross the river. And he says, like, I don't care about the river and all, I'll swim straight. We'll see what happens. So this man swims straight. Swim straight with V. That is, he's always looking ahead. Or you can say it's always perpendicular to the river flow. He's always looking ahead. Like case 3, the man doesn't care about the river, just going straight. The first question, find velocity of the river as function of y. Now this is more of a max. So it is 0 at y0 and it is u at y is equal to d by 2. Find the velocity of the river as function of y coordinate. Find time taken to cross the river. And the drift. Find equation of the trajectory and the drift. Or you can say draw the path of the man. So how is this man swimming actually? Find the equation of the trajectory and drift. Drift meaning since he's swimming straight, he won't go straight. He will reach other side somewhere else. Where did he reach? Let's get these three questions. So if it is an exam, I'll ask you B and I'll ask you C. I won't even ask you B actually. I'll ask you C only. I'll ask you which of the following is the trajectory and the minimum drift. So let's see. That's not the full answer, Anish, for the first part. This word is important. You will see this a lot. The function increases linearly, velocity increases linearly, charge increases linearly, the magnetic field increases linearly. You will hear that word a lot. And it will be quite useful. So this is the first time you're seeing that. So when I show you, remember that. Next time when you hear the word linearly, you should know how to handle it. But yeah, you give it a try for a minute or two. Then I'll show you the first part. Anyone didn't understand the question or the story, ask me. I know there's a lot on that page, but I hope you got the story. So this is close to an actual river. Till now, what we did was a fake river. They don't flow like that. This also, we took a big approximation. It is linear. Tomorrow, they will say it is increasing as a square function. You should know how to handle that. Yeah, you got the B part. That was the easiest one. Dhruv, you got the part of an equation. Remember, the equation will change from 0 to d by 2 and d by 2 d. You have two different equations. Okay, let's see the first part. Listen to this thing. Whenever someone says the function is linear, meaning it looks like y is equal to mx plus c. No, that y could be anything, velocity, energy, anything. Y is equal to mx plus c. So if velocity varies linearly with y, this is how you should write. V is equal to, you can write like a into y plus b. That's a function. So a and b are constants. So if I can find a and b, my job is done. So be careful. You have to split this thing into two parts. The value between 0 to d. These are very easy to do. If you put y is equal to 0, v must be 0. So that will be a into 0 plus b is equal to 0. Therefore, b is equal to 0. At y is equal to d by 2, v is equal to u, or you can just substitute here, a into d by 2 plus b is equal to u. But b is anyway 0. So a is equal to 2u by d. Then that means your answer will look like this. So velocity is given by 2u by d into y. But remember, this is only valid till, my mistake, d by 2. This is more of a math thing. Then y between d and d by 2. So the function will change. So again, same thing. We'll write v is equal to pv, py plus q. I'm not using a and b because it will be confusing for you. So p and q are constant. That's the meaning of a linear function. Just put constant into y plus constant. And then they'll always give you the initial data. At y is equal to d by 2, v is equal to p into d by 2 plus q is u. So that's one equation. At y is equal to d, v is equal to, again, p into d plus q is 0. Two equations, two unknowns, subtract them. You end up with p is equal to minus pd by 2 is equal to u. We get p is equal to minus 2u by d. And q ka value will be 2u. Q will be minus pd, that's 2u. Done. So your velocity will be minus 2u by d into y plus 2u. Yeah, this is the equation once you cross the midpoint. Are you clear with this? This is the velocity of the river. So if you just give me this thing, it's a wrong answer. You have to tell me both. So if you try to plot the graph for this, v versus y graph, you can clearly see the first one is a line passing through the origin. Then second one is a line going like this. So, and this is the peak velocity u. This is how the graph will look. It's increasing and then decreasing. All clear with this? There is no physics there. This is pure math. Y is equal to mx plus c. You're putting the values and you're checking there. Great. Let's do B and C. How did you take U? Is U same everywhere? Is the man moving with U horizontally everywhere? How to get the time and how to get the drift and how to get the equation. Now, one thing here, we can be very sure whatever happens from 0 to d by 2, same thing happens in reverse from d by 2 to d. So if I can do the first half, the second half I can simply say double and I'm done. So that's one advantage of symmetry. It's time, right? Time is right, Anna. Any ideas for the time? People can type your answers. If you got the drift, also type your answer. They're really not that bad answers. Okay, let's see the time part. I thought you guys will say that. Tell me one thing. When you're crossing the river at any time, if you take that man at any time, he is struggling with his own speed v, and the river is just dragging him this way, which is not constant. Simple question. Will the river ever help him to cross the river? No, right? River will not do anything. That means the only reason you're able to cross the river is because of your own effort. So time will be d by velocity, right? That along that AB. So velocity along the width. And the river ka velocity is zero in that direction. So this is simply d by v. This is independent of river ka speed. The river will only drag you horizontally. It will never push you to cross the river. The B part is clear. Now, what about the C part? Think. I'll give you a minute or two. Think how to handle the C part now. Okay, let's see. X is u dy to v. Yeah, right, Risha. You got the equation of trajectory also? Oh, so you will need it anyway to get this. So how to do the third part here? C. Now, how is he going? We don't know. That is the first thing. We don't know. So maybe he's going something like there's some weird path. Let him go however he wants. So at that instant, if you look at the velocities, he's trying to go straight with v, and this is your v river. Let the coordinates of this point be x comma y. Now look at this clearly, okay? The only reason you're going in y direction is because of the Manka speed. So we are choosing this as your y-axis. This was your y-axis. So the y coordinate is simply velocity of the man into time. The river will never change your y coordinate. So indirectly, I got the y coordinate. Y is equal to vt. That is a big advantage. Great. The next thing, what is velocity of the river? Velocity of the river, we are doing only from 0 to d by 2, is how much? We calculated 2u y by d. Now, one mistake what people do here, they'll write this thing as dy by dt and they try to solve. Be careful. River is flowing in which direction? X direction. So this should be dx by dt, which is 2u y by d. Are you clear with that? River is in x directions. How can you write dy by dt, right? So this is dx by dt. But what is y? 2u by d, y is vt. Now I can integrate this. This will give x is equal to 2uv by d t square by 2. Then I got my x coordinate also. uv by d t square. That's my x coordinate and that's my y coordinate. So if you take time from here and substitute, you will get x is equal to u by v d x square y square. This is a a parabola, which I'll write in the next page. So far clear, everyone? So you got the y coordinate, then you get from V river, we get it there. Any doubts on this part? Now, once you got this, you're done. So then you have y is equal to Vt, and then we have x is equal to uv by dt square. So take t is equal to y by v and substitute here. So we get x is equal to uv by dy square by v square. This will be u by dv into y square. This is again, if you don't remember, if you have a parabola like this is a y is equal to x square parabola. If you have a parabola like this, if you make the parabola horizontal, then this is x is equal to y square. So horizontal parabolas will look like this. So this is a horizontal parabola. This is x is equal to uy square by vd. Again, this is only valid from d by 2. We are doing only for the first half. Perfect. So if you want to draw the trajectory, how does it look? So let me calculate that also. So for y is equal to d by 2, the x coordinate will be d square by 4. You get a u d by 4v. Yeah. Okay, so we got all the data there. Now let's see how the path will look. This is the midpoint there. So the river is flowing horizontally. This is how this guy will go. So this will be a parabola like this. The axis is going in a curve. And once you cross here, you can see by symmetry, this will be like this. Reflection of it. Look at the man ka velocity. So this man is always going straight. He doesn't care about the river. He's always swimming straight. As you go into the center, the speed of the river is increasing. So you're getting drifted more and more horizontally. Once you cross the center, the river is slowing down again. Therefore, you can see he's becoming straight again. Once you reach the other side, river is gone again. So if you look at the river curve velocity, this is how it looks. So here V river is 0. Here there's a small V river. There is a V river. Here there is a V river is increasing. Then again it is decreasing, and again becomes 0. So from here to here, we calculated this. So UD by 4V. So this distance is UD by 4V. So by the time you reach the center of the river, you will travel UD by 4V. By symmetry, you can see the same thing happens on the other side. This will be UD by 4V. Therefore, the total drift will be UD by 2V. That's your drift and that's your trajectory. Is this clear, everyone? How is this guy going? He's not going in a straight line. He's actually going in a curve. Clear with this? Suppose exam may they give you something like this. Let's say if I give you 3 options like this, how will you guess which is the right one? Now say again, I tell you, when you guess, you don't know what is the right one. What you can do is guess which are the wrong ones. Now we know this is the answer, right? That's what we got approximately. So now you tell me what is wrong with this and wrong with this. Guessing is always about eliminating options. If these are the trajectories, how do you know the first one is wrong and the third one is wrong? I could give you more options, but yeah. How do you say like, oh, this is definitely wrong? Because the exam, you can't do random guessing. If you can guess with your knowledge, you will be confident to mark it. How do you know first one is wrong? Because if you just want the trajectory right, I would not solve. I'll try to guess from this thing. I told you this before. Exam first 10 seconds, I will try to see if I can guess. If I can guess, I'll go ahead with that. You guys thought about something? Listen to the logic. At the initial point, what is river ka speed? 0. What is the man ka speed? V. That means at t is 0, the man is going this way and the river is 0. So the resultant vector should be in the upward direction, isn't it? But look at the path here. It is going horizontally. That's why it is wrong. You get in the logic there. At this point, if you see, right, even if you ask me frankly, even this would be wrong. I should have drawn like this. When you're leaving from the river, you should leave perpendicularly. You should be leaving perpendicularly. And then when you're entering perpendicularly, because when you're at the bank of a river, there's no river velocity. You're hitting the river perpendicular to it. So this also would be wrong because this angle is not 90. This is not 90. That's why that is also wrong actually. This is also wrong because look at the center of the river. Even if I take this to be 90, the mistake I did here was this. At this point, you have a river ka man ka VM and V river this way. You can never become horizontal, isn't it? That path became flat. That is wrong. So the curve will just make a turn there. So that's why that is also wrong. Is that logic making sense? So you can just see the trajectories and figure out from there. So yeah. Okay, take a break. Come back by 9:45. We'll continue from here. So any doubts on this? Anything else? Please ask. So come back by 9:45. We'll continue from here. Yeah, let's go ahead. So that's a little bit about Riverman and all that stuff. The next thing, there is another variation of these problems. These are called flag problems. So during World War One, right, when people were fighting on ships, so we didn't have any radars and all that stuff. So how do you know how the enemy ship is actually moving? How do you roughly approximately guess and shoot your shells towards it? And most of the ships were based on steam ships. So basically, by looking at how the steam is going, in which direction is going, you can roughly predict with what speed it is going. So let's see what happens. How does this flags behave? So consider a flag on a vehicle. Case one, let's say wind is blowing and vehicle is at rest. Then what will you notice? The flag will go in the direction of the wind. Yes, straightforward. So the wind is blowing to the right, the flag also will point towards the right. The same thing with a steam also, or maybe smoke. Let's say we have a chimney there and smoke is coming out. So the smoke also will drift in the direction of the wind. Great. Others, do keep your cams on. Case two. Let's say there is no wind and the vehicle is moving. Remember last time when you're sitting on a bike or a scooty, right, and you put your hanky or something, how was it moving? It was going opposite to the vehicle. You're going in a scooty, the cloth is going back. So let's say we have a flag like this. So if the car is going forward, this thing is going backward. Flag points opposite to the motion of vehicle. That's it. So what happens if you have both? What if the wind is also blowing and what if the vehicle is also moving? That's what used to happen with the ships. When the ships are moving, these all are based on the steam things. Steam is coming out, the ship is moving, and if you know the wind gust speed, you can predict the angle. Maybe not exactly, but roughly, even if you get a velocity, right? It'll be useful. So when you're shooting down the enemy ship, you just need to have a rough estimate. Then you can start firing. So let's see how will they can frame a question on this. A vehicle with a flag moves east with 10 meters per second, and wind blows northeast with 10 root 2 meters per second. In which direction does the flag point? Yeah, get this in the Hmm, okay, let's see. Let's go one step at a time. How is the vehicle going? East. So flag will go which way? West. You'll go opposite to the vehicle. Remember our directions? We will stick to the standard north, east, west, south. So if the vehicle goes towards east, the flag will go towards west. So this is due to vehicle. How is the wind blowing? 10 route 2 towards northeast. So you will go with the wind. This is due to wind. Yeah, done. That's it. So just get them vectorially. This would be 10, and this would be 10, and this would be 10, and you can see horizontally cancels out. So what's left is this 10 meters per second. So the answer is north. The flag will be pointing towards north. Easy? Yeah, let's see one more like this. So let's say we got a big river. The river is flowing with 20 meters per second. You have a boat. The boat is going with 10 meter per second. So this is the boat moves with 10 meters per second in still water. So this is the velocity of the boat in still water was 10, and you're trying to go straight, but you won't go straight. So the boat is always looking forward. At the same time, the wind also started blowing. The wind is 10 root 2 meters per second southwest. So every damn thing is happening there. Now, in which direction does the flag point? Something like that. Nee, Yukti. You won't get a good answer for this. South of west. I think that is right, Anish. Don't see all three at the same time. Look one at a time. What if the boat was there in the river? No wind, the boat is not moving. What would have happened? It will go with the river, isn't it? Mm, yeah, you should say na. How will you, if you just say southwest, then it will be 45 degrees. Mm. No, 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 don't be sorry and stuff. Why are you guys using such big words? Get it corrected. So let's see. First thing, if the wind was not blowing, if the boat was not going, the river will drag you towards east. So if the boat is going towards east, you will get 20 meters per second towards west. This is due to river. So understand the river will simply increase the speed of the boat. So it will be opposite to that. Now, because boat is going towards north, the flag will point towards south. This is due to boat. The wind is going southwest, so the flag also will go southwest. That is the only thing. So flag will go towards the wind, but flag will go always opposite to the boat. Yeah, and then you're done. You just have to get the vectors there. So that's 20, that is 10, 10 and 10. So we got 30 and 20. You can take angle however you want. So I will take this angle alpha. Then you get tan alpha is 3 by 2. So we can say it is making a, you can take alpha as the other one also. Nothing wrong with that. So board moves tan inverse 3 by 2. This angle is what? West of south. So from south, it is that. If you take the other angle 2 by 3, then that you will say south of west. Both are right. Both are right. You have to check your options, which one is there. Or you can say tan inverse 2 by 3 south of west. Hope everyone is clear with that. Both are right. So always see the options, like based on that you have to do. So that is one more category of questions in relative. So if you see in relative motion, right, what all things we did so far? We had riverboat, man, and the riverboat problems, man and the rain problems, flag problems, particles chasing each other, cat dog problems, the triangle ka particle chasing particles, the minimum distance between the two particles, condition for collision of two particles. So relative is the good one. Like kinematics, if you see, right, this is one thing you have to be really careful. So that's a bit about relative. And the last thing we're left with is graphs. So maybe today we will do a few parts of it. Mostly next class, we should be able to wrap up. So graphs, you only have two simple things. Okay. And every graph will give you normally two important quantities. So if you take a graph, and this is based on calculus basically, you can get a tangent. Or you can get area under the curve. These are the two main informations. The slope of the tangent is dy by dx. Area under the curve is integral y dx. Now, depending on which graph you take, the quantities can have different meaning. Now we have five standard graphs. The first graph is position time graph. So if you take an xt graph, so in an xt graph, the slope is dx by dt, which gives you velocity. So in an xt graph, slope is velocity. Area is integral x dt. What is position into time? Nothing. So there is no meaning here. So area is meaningless here. So we don't use this. That's it. So xt graph primarily gives you the slope is velocity, right? But more than that, the interpretation is important. So let me give you that. Listen to this thing. Let's say someone gives you a graph like this. Let's say this is 60 degrees, and let's say this is 5 seconds. Understand the meaning of this. The meaning of this graph is the body is starting from, body is not at rest. What is the speed here? The slope is tan 60. The body starts from origin. So seeing a graph, you can tell what happened with the body. It started from origin with root 3 meters per second. This is 5 root 3. And after 5 seconds, it stopped. Velocity became zero. Slope became zero. It stopped at 5 root 3. There. That is the scenario. So looking at the graph, you can tell what happened with the block, how it moved and everything. So if I have to draw a picture, this is how it would look. The block started from x is equal to 0, traveled with root 3 meters per second. Then it reached x is equal to 5 root 3 and it came to rest. Because look at this, after 5 seconds, the graph x coordinate was constant. Clear what happened there? Now, the same way, I'll give you a graph. You have to give me the data, okay? Let me give an example. You have to tell me how the block moved. XT graphs, right, are one of the, like, what is a, people think you don't get enough information, but there's a lot you can drag from it. Let's say the graph is 60 degrees. Let's say this is 45 degrees. Let's say this is 10 meters. This is 5 meters. Yeah, this was the thing. Can you tell me what happened? Just roughly, like whatever information you can pull from this graph. Whatever you can think of. Yeah, examine, they can ask you anything, but look at the first graph. At t0, the particle is at 10 meters. It's not at origin. When t is 0, x is 10. So body starts from x is equal to 10. And look at the slope. Slope is, you have to take the other angle. It is going back. So tan 135 goes back with 1 meter per second because the velocity is negative, right? And at 5 meters, the velocity changes. And at x is equal to 5 meters, speed becomes root 3 and then reaches origin. If you touch this line, meaning x became 0. We can calculate the time also, but he can. So if I try to draw the picture, this is how it looks. The body is actually starting from here. X is equal to 10 meters plus t is equal to 0. You're going back with 1 meter per second. Remember, when you take slopes, you should take the obtuse angle. Right? So tan 135. This was slope tan 120. Minus indicates you're going back. Then you reach somewhere here at x is equal to 5. And at this point, your speed became root 3. And then you reached origin. That's what happened. Now, can I tell you something about these two? There are two particles. And I draw the graph for both the particles. Something like this. Just one or two sentences. What do you think happened? Just tell it to yourself. When I explain, you can see whether you got everything right or did you get even more points. So looking at a graph, you should be able to tell what happened with the body. So these things, right, they'll be framed as statement questions. I'll show you next one how they'll frame it as statements. So see, we have a particle 1 and particle 2. Particle 1 is starting from x is equal to 2. With speed root 3 meters per second. Particle 2 starts from x is equal to 3. Basically, 2 is ahead of the first particle, but the speed is less. It's 1 by root 3, tan 30. That means the guy behind you is definitely going to cross you, and it happens. Look at this point here. At t is equal to t naught, uh, which we can find both the particles meet. That is a time when both the particles have same x coordinate. That means both are side by side. Yeah, that much you can get. Clear with this? So now I will give you a graph. You have to tell me like what is happening. 60, 72. We have an XT graph. Let's say this is 3x naught. Let's say this is x naught. This is a horizontal line. The graph starts from here. It decreases, 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 but it's getting closer and closer to the line, but it never touches the line. What happens to velocity and acceleration? So in the exam, options will be like this. The velocity, the speed is always increasing. The speed is always decreasing. Speed is increasing and decreasing. Speed is decreasing and increasing. The acceleration is always increasing. Acceleration is always decreasing. Acceleration is always positive. Acceleration is always negative. Velocity is always positive. Velocity is always negative. They can ask a lot of things. It's a matlab, they can play. So you tell me. So we will do everything. We will literally find out what is velocity and acceleration doing for the whole thing. So exam they can make up any four options based on acceleration and velocity. What do you guys think? So I'll tell you what, simply enough, tell me two things about everything. For velocity, tell me what is the direction and tell me whether it is increasing or decreasing. Acceleration, tell me the direction, tell me whether it is increasing or decreasing. Bus. That's it. Those are the two things you can tell. Which way is the velocity? Forward or backward? Is it increasing or decreasing? Acceleration, forward or backward, increasing or decreasing? Think, take a minute. And remember, you know only one thing. The slope in a xt graph is velocity. You don't know anything else. And they're asking about acceleration. That's where it stumps the people. Like, how the hell we get acceleration from xt graph? You don't want a value. We just need some kind of a thing like what's happening. Hmm. Okay. Think for a minute. I'll show you one. I'll give you one more like this. Mm, mm. You're not touching that. So it's becoming, it's getting closer and closer to x naught, but you'll never touch x naught. Line, there is not a line anywhere. It's just a curve. Mm. Listen, I'll show you one. What I'll do now, I will take some numbers for convenience, okay? So I'll just draw a new one. When you get confused seeing the numbers always help. Just let's get the slope. So at this point, it is very steep. So slope will be something like -10. Somewhere here, the slope will be, as you're coming down, you can clearly see, right? The tangent is becoming less and less steep. So here slope is velocity. Now, how did I get the number? Random. I'm just putting any numbers I want. And then when you're here, you'll see -3, you'll see -2, then you'll see it is -1, and then you'll see minus 0.1. And if you see, right, this is getting closer and closer to becoming flat. If you look at the numbers here, this will be something like -0.01, and this will be like -0.001, and so on. Matlab, you are never going to zero. You are decreasing and decreasing, but you're never going to zero. Now just look at the numbers. First of all, is the numbers increasing or decreasing? Magnitude is increasing or decreasing? Magnitude is decreasing. Agreed? What about the direction? The velocity is always negative. It is decreasing, but it is always negative, isn't it? Means what? The particle is always going back, but it is slowing and slowing and slowing, but it is always going back. It is never stopping. Are you getting? So here we can see the observation slope is always negative, meaning the body is always pointing backward, but decreasing in magnitude. Slope is always negative. You're always going back, but you're decreasing in magnitude. Means you're going slower and slower, right? And so if you look at the body, this is how it looks. So this body started from x is equal to some 3x naught. Initially, you had some good amount of speed, let's say 10. When you reach here, your speed became 5. When you're here, it is 1. When it is here, it is 0.1. And when you're here, it is 0.01. You're going closer and closer and closer, but there is a limit. You will never cross x is equal to x naught. You're trying to get closer and closer there, but yeah, you're never going to reach there. This will be like 0.00001 and so on. The more closer you get, the more slow you become. Now, from here, logically, this is the velocity. If you're going back and slowing down, means acceleration in which direction? Right side, isn't it? If your speed is decreasing, meaning acceleration is backward, it is speeding down. Is that making sense? So V is backward, but A is forward. Any doubts still there? What can you tell about A ka magnitude? Just think about it logically. From here to here, you went from 10 to 5. From here to here, you went from what? 0.1 to 0.01. So for the same time, your delta V is becoming smaller and smaller and smaller, isn't it? Your velocity is changing much lesser for the same time intervals, meaning your acceleration is decreasing in magnitude. There, now we have all the data. So velocity is negative or backward and decreasing. This particle is speeding down. Speed is always decreasing. Acceleration is forward, is always forward. And this is also decreasing. Right? And you can see that simple logic there. If you take acceleration dv by dt, for same dt, you can clearly see that delta v is decreasing, meaning even if you take average also, you will notice. Average acceleration delta v by delta t, that I think mathematically is more easy to see. For same time interval delta t, delta v decreases. Initially, in 1 second, you'll decrease 10. After a long time, 1 second, you'll decrease negligible amount. Is this all clear? Acceleration is always decreasing, but it is always forward. And will you ever cross x is equal to x naught? You'll never cross. You can tell even about that. So particle is always getting closer to x naught, but it will never reach x naught. Is always moving towards x naught, but will never reach. This is all the data you can pull. All clear with this. Let's see one more like this. You guys tell me what is this. So just try to tell me what is the velocity ka direction, acceleration ka direction, increasing, decreasing, bus. And that much you know, then you literally got everything. Let's say this is 20 meters. This is minus 50 meters. What can you say about this graph? You can check out with the slopes. I put numbers, so that it'll be easy to see. But yeah, that's more kiddish way of doing it. For some reason, I like to put pictures and numbers. When I see them, I feel like, this is what is happening. It's more clear. But if you can do without all that, that's also great. Same thing. Velocity ka direction, increasing or decreasing. Acceleration ka direction, increasing or decreasing. That's it. You got me that? You're done. Done. Oh, again, check out the slopes. If you look at here, it is very steep here, then less steep, then less steep, and then less steep. So yeah, and the slope is positive here. It's always making acute angle. Slope is positive. So again, I'll put some numbers for convenience. Plus 10, plus 5, plus 2, plus 1, plus 0.1, plus 0.01, plus 0.001, and so on. That you can clearly see these are the velocities. So what is happening with speed? Speed is always positive. It's always going forward and decreasing in magnitude. So it is actually speeding down. What about the acceleration? So the particle is always going front, so acceleration is negative. It's always backward, and that is also decreasing because if you look at the delta v, it is decreasing for the same time. And what about the particle? It is starting from x is equal to minus 50, and it is trying to go towards 20, but it will never reach 20. Clear? I hope it is clear now. When you see a graph, how to figure it out. Let's see one more like this. XT graphs are one of the most neglected things. Like people feel like, oh, there's nothing inside. So we got a sine graph like this. A, B is the peak, C, D, and E. So there are 5 points there: A, B, B, C, C, D, and D, E. In which region particle is speeding up? Thus, there'll be four options: A, B, B, C, C, D, D. You know the meaning of speeding up. Hmm. नहीं श्लोक xt ग्राफ में स्लोप इज वेलोसिटी. Look at your slope का magnitude. Is the magnitude increasing or decreasing? So speed increasing or decreasing? We don't really care about the direction for speed. Okay, let's see. DE. Okay, let's check the slopes. You will notice it. Look at the slopes here. So here the slope is steep, positive. The slope is decreasing. Slope became zero. Then slope became obtuse angle negative. It became more steep here, but more negative. Then it's becoming less negative, and then zero, positive, more positive. If I have to give you some numbers, this is how it will look: plus 10, plus 5, 0, minus 5, minus 10, minus 5, 0, plus 5, plus 10. Some random numbers, okay? That is how the slopes will look. Now you can clearly see in which region is the magnitude increasing. A to B, magnitude is decreasing. B to C, magnitude is increasing. So B to C. C to D, again you're going to 0. And DE. You can clearly see speed increases. Or you can say slope, magnitude of slope increases. We don't want the sign. Therefore, speed increases, speeding up. Is that making sense? Easy? Since I'm asking for speed, I don't care about the sign. So I'll just put some numbers for convenience. It looks more easy with numbers. But mathematically, you can always say slope ka magnitude is increasing. Any doubts on this? So there are 2 points where it is speeding up. Automatically, the other two you're slowing down. Let's do one more. This is an XT graph. Hmm. This is plus 100 meters. This is minus 100 meters. Here, if you draw a tangent, this will make a 120 degrees. Here, if you draw a tangent, it makes 120 degrees. This is 10 seconds. This is t is equal to 20 seconds. This point is A and this point is B. So a particle is going from A to B in this weird curve. Find average velocity and average acceleration when you go from A to B. So in XT graph, if they start talking about acceleration, right, those are little good ones. Like this is an XT graph. Find average velocity and average acceleration. Let's finish off. This will be the last one for the day. That's little about XT graphs. Next class we will do VT graph, AT graph, and all that other stuff. Non-standard graphs. Any answers? Always go with the definition. Ask yourself, first of all, what is average velocity? Average velocity is displacement by time. Average velocity is x final minus x initial by time. I really don't care about the curve. What is x final? Minus 100. What is x initial? 100. What is time? 20 seconds. So what is this? Minus 200 by 20, minus 10 meters per second. Make sense? That's it. We really don't care about anything else. People look at that curve and they think like, oh, we should do something about it. You need not do anything. What is average acceleration? These are averages. You don't care exactly what is happening at every instant. V final minus V initial by time. What is velocity in the graph? Slope. So what is V final? Tan 120. What is V initial? Tan 120. Time is 20, 0. Your initial and final velocities are same. The graph is just to scare you. कुछ नहीं था graph में. All clear with this? So just people see that graph and think like, oh, something else is happening. So go with the definition always. I didn't ask you for instantaneous. All clear with this? There, so that's a bit about the graph. You're understanding how you can play with the graph, slope, and analyzing and getting stuff from there. So next class when we catch up, I think we'll be almost done, and we'll wrap up with that. Maybe little might be spillover. And after kinematics, we will go with units and dimensions and errors. So that's one chapter we need to do. Because every chapter may they'll ask you errors and all, so you will not a big chapter. I think it'll take maybe 2 to 3 classes, but quite an important thing. In advance, every year they ask you at least 2 questions on errors combined with some other chapter. So we are going to do that before going ahead, and then after that we'll start off with loss of motion, friction, and all that stuff. So, okay, we have done almost 75 questions. So please make sure to go through the whole stuff, right? And yeah, maybe I'll send you some practice sheets also in the group, so you can do that. But again, remember, don't run between too many materials. Finish your classes ka thing, your standard books thoroughly, and then go for additional. You already received my booklets. In my booklets, if you see, there's a level 5 and level 6 also. Those are some really good questions. You can try them if you're done with your classes ka material. But in case you're finding your classes ka material difficult, then you can go level 1 to level 4 in my booklet. So there are 6 levels and everything is graded, gradually. Level 1 is easy, level 2 is thoda moderate, 3 is little more, 4 is fine, 5 and 6 are tough. So you can choose from that and you can do. Okay, with that we'll wrap up for that day, right? And I'll see you guys again next Monday. We'll continue from here. And do remember there's a test on Friday, so make sure to give. So any doubts, anything else, please stay back and ask, or else you're free to leave. And see you again soon. So take care, stay safe.